Hi everyone, this is Rama Anand. Here we are going to talk about the project, text mining project called Cuisine Classifier. The team members are Naveen Kumar Palani, Rama Anand, and Santa Kumar Subramanian. Let me give some background about the project. Digital news articles has become part and parcel of our lives. We heavily use it to express opinions, judgments, and to make any decisions based on any kind of topics. So the lack of system to find the categorized cuisine from a set of food-based articles make it challenging for the users to make decisions based on food articles. This proposed project, we are going to address that problem where user can find cuisine categories based on set of food-based articles. This project is based on statistical model and which classifies the cuisine types based on ingredient lists. And also this project classifies the meal type or dish type based on ingredient lists. We also have implemented a web interface in this project to smoothly navigate into different fields that was generated from this model. So this web interface can be used by the user to explore the different cuisines and ingredient lists and dish type and things like that. And also to go to the source of the food-based articles. This tool or this project can be utilized by any search engine, or also it can be used by websites based on food or recipes websites. This project can be utilized into by those websites, or can be utilized in search engines also. This project is not available as it is in the net. However, there are some tools which are based on food, which does similar classifications. Actually, there was a paper which was published in past, which is very similar to our project. However, in our project, we have classified many more cuisine types than the paper has identified or classified. Also in our project, we have classified a meal type or dish type to be a vegetarian or non-vegetarian. The implementation part will be covered by my team member, Santa Kumar. So he would be covering the implementation and details on that. Thank you, everyone.
Hey Rama, thank you for giving a brief introduction to our project. Now I will go through the implementation part. And as Rama explained, this tool, the Cuisine Classifier, is a statistical based model which is classifying the cuisine, like recipes into different cuisine types or food type, whether it is vegetarian or non-vegetarian. So as it is being a statistical model, we always need some kind of training data to train the model so that it can be used to do future predictions. So to train the model, we identified some data availability in Kaggle. So we used that data to train our model. And we also thought to use some kind of data to test the model once it is implemented. So we took the data from BBC website. So we are going to use that to demonstrate how the model works, and we will also be helping you explore that results in a web page, whatever we have built. This tool is built on a Python platform, and we have used the latest version, which is Python 3.7. And to explain the implementation in step by step, I will go to the Jupyter notebooks to go through the steps. I will go to the Jupyter notebooks now. Yeah, so this is the Jupyter notebook which we used for the implementation, and this is named as Classifier, and we have uploaded this notebook for your reference in the GitHub repository, whatever we have provided for you. And as I explained, we initially scraped the data from Kaggle, and we imported that data into the Python environment. As the data was available in JSON format, we used the dictionary data type to import the data into Python environment. Once we import that, we converted the data into Python data frame in the next step. And we also identified that there are a lot of special characters, punctuations, and few words were available within the parentheses. And there were also some trademark symbol for the food ingredients available in the data set. So the better way to approach this problem is first to cleanse the data and then to use the data to train our model. So we used the var net lematizer function and regular expressions to cleanse the data. So that's what we have done in the step 5. So this particular step will remove all the special characters and parentheses, whatever I mentioned. And once the data is ready, we can use that to train the model. But as I told earlier, in addition to classifying the cuisine type, we are also classifying the ingredients or recipes into whether it is a non-veg recipe or it is a vegetarian recipe. So to do that, we need that information in the training data set. But the data set from the Kaggle doesn't have that information, whether that particular recipe is a vegetarian or non-vegetarian recipe. So we use some kind of rules to say whether that particular recipe is a vegetarian recipe or non-vegetarian recipe. The rule we used is to go through the ingredient list and see if this words, whatever I have mentioned here, like fish, goat, or any other meat items, whatever available in this list is available in the ingredients. If it is available, we have marked that as non-vegetarian. If not, we have marked it as vegetarian, so that this particular data set can be used to train the model to classify the dish type. So once that is done and the data is ready, we have to use that to train the model. Like as I mentioned, it is a mathematical model. We have to convert all the text, articles, or words into like some either a vector or a matrix. So to do that, we have used TF-IDF vectorizer, which has some inbuilt functions like to remove the stop words like the, or, and, or something like that. So the TF-IDF vectorizer will remove those stop words, then use some analyzer function and to vectorize it as an individual word or as a pair of words. And we also have used the internally available stemming function before we convert the data into vector format. So in this step, we are doing the steps and converting the data into a mathematical vector or matrix format. Once that is done, we have stored that in this vectors x, y, and z. And to train the model and test whether it is working fine or not, we have used the training data in 80-20 ratio. Like 80% of the data will be used to train the model and 20% of the data will be used to test the model. So once that split is done, we have used multiple algorithms available to see whichever algorithm is performing better for this classification problem. So first we tried naive Bayes algorithm, and then we tried logistical regression and SVM algorithms, and you could see the results for each algorithm. And the naive Bayes produces an accuracy of around 66%, and the logistic regression produces an accuracy of around 77%, and SVM algorithm produces the accuracy of around 78%. And the individual category level accuracy and precisions were also better with SVM. So we decided to use SVM model for our project. That is to build the classifier, Cuisine classifier model. So we use that algorithm to build the model. and then in the next steps we are going to use that model to predict the some of the test data what we have scraped from BBC website. So to scrape the web data from BBC website, we use some tools which are already available on the website, like web scraping tools. So we use that tool and scrape the data and store it in the CSV format. So to import the data from CSV, we have written some code here and which will import the data from CSV into Python data frames. And then we did the same word net lemmontizer functions to lemmontize the test data and remove the special characters if anything available in the test data, and then use the same tf-idf vectorizer to convert the test data into a vector or matrix format, so that both the train data and the test data are in the same format to test it with the model whatever we have built. So that's what we are doing in this step. And in the next step we are giving that matrix or vector into the model and asking it to predict. So once the model predicts it, it will be either in one of the Cuisine type and one of the dish type, whether it is British, French, or Indian or something like that. These are the Cuisine types. There are list of Cuisine types which the training data had. So those are the only Cuisine types which the model will predict. So we have given that list in the README page, and the dish type will be either vegetarian or non-vegetarian. So once the model predicts these things, it will be stored in the CSV files, which is named as output.csv. And we have also uploaded this CSV in the GitHub repository, so that this file can be used by the web interface to help you explore the data in a better way. So yeah, this is how we implemented the project. Now my teammate Naveen Kumar Palani will go ahead and explain how to use the tool by setting it up in your local machine and how to use the website yourself.
Thank you, Shantakumar. So I'm Naveen Kumar. I'm going to explain how to use our Cuisine Classifier tool. So we have published our work in the below GitHub repository. Now I'm going to take you to the GitHub repository to show you how to fork the project. So if you see in the GitHub repository, there will be an option to fork a project. If you click on the fork, so it will fork the project into your own GitHub ID. So it will take 20 or 30 seconds to fork your project. Once it gets forked, and you will see you'll have to click on the settings tab, and once you click on that one, you have to scroll down, and there you will find a GitHub pages section where under the source you will find the master branch option. You have to select and save that one. So once you save, you will get the URL generated. So this is the actual URL that for your GitHub repository. So once you get this URL, so for you in order to use the web interface, you have to take this URL and attach at end your HTML file name, so that you can access your web interface. This is how you can access your web interface. So going back to the slide. So now I'm going to explain on so there are two options to use our tool. Either you can fork the project, which is how I showed you, or you can directly download the repository into your local machine. So if you want to see the output in a web interface, you have to fork the project using the clone or download option available in the GitHub repository. So if you use that one, it will download all the files in your local GitHub repository. By the way, you can use the web interface. If you do not want the web interface, you can just directly download the repository into your local machine and use it. So in order to use the tool, you need the latest Python and the Jupyter notebook installed into your machine. And these are the following folders that you can make use of it when you're downloading or developing your own tool. So there is in a main folder, there is a classifier file, which is a actual Python code, and there will be an output.csv file, which is the actual outputs which we arrived from our model when we develop our tool. So there is a subfolder they call data folder. Inside the data folder, you will find a train data and a test data folder. So the train data folder, you will have a train data, and in the test data folder, you will have the test data. The train data is in a JSON format, and the test data is in a CSV format. Make sure that you use the same when you develop your own tool. And so in order to run the classifier file, you need to open the classifier file in a Jupyter notebook. And see, if you want to use your own training data, you have to provide the training data in the train folder. It should be in a JSON format. So you can very well have a reference from your from our repository, which is already available. And say if you want to provide the ingredients for the recipe, you want to give the ingredients in a CSV format, and then you have to place that in a test folder. So yeah, once you placed all this, if you want to run that classifier file through Jupyter Notebook, in Jupyter Notebook, either you can run the chunks, I mean each chunks, or you can run whole project by using the run all command. We showed that in the below screenshot. Once you run that run all command, once you're in the project, so you will have your output in the output.csv file. Once you have the output from our classified model, I will take you to the web interface to show the results. So in the web interface, as I said earlier, like you have to use your repository URL along with your HTML file name so that you can access the web interface. So in the web interface, this is the default page where you will have all the data, recipe data that is displayed from your CSV file. And the user has the ability to filter the data like either cuisine, either by the cuisine type or the veg and non-veg type, and cook time or the effort. So if they say if the user is interested in like British, so he can select the British, and data will be displayed, the recipe data would be displayed related to British. And say user is still more interested in like knowing like getting non-veg, from the veg or non-veg tab, he can select the non-vegetarian, and you would see the British with the non-vegetarian. Likewise, he can select the cook time, he can select the effort, like this. So there is one more option in the left where you see the expand and collage button. So if you click that one, you will see the ingredients that are used for to make that particular recipe, and how the recipe has been made, like the cooking method. And there's one more additional option here. It's like you can go to the recipe URL. This is the actual recipe URL from where we actually scrape the data for the project. So here you could find all kinds of details like prep time and the ingredients used, the cooking method. So these kind of details, everything would be found in this website. So going to our web page, and there is one more option for the user. Like he can select, he have to default all the values to null, and he can go back to the search button. So text box, he can say if he is interested in chicken, he can type chicken, and if he's typed the chicken, all the recipe irrespective of the cuisine, he will get the recipe related to chicken. So now you could see all the recipes that is related to chicken here. So this is how you use a web interface, and you can filter the results and you can view it whichever the user selects. So if you want more details about our project, you can very well go to our GitHub repository README page. You can find all kinds of sort of details about the project. I hope you enjoyed our project and the project presentation. Thank you.